Hey everybody, I'm Dan from Project Blue, here to talk about modernizing legacy IT systems. Last time we talked about how our current tool set may be dated. While it works, there's probably a better opportunity. What's the desired end state? Today, we're going to talk about platform-independent distributed architecture, or cloud computing. What is all that about? Up front, this isn't just a good idea. This isn't just Dan talking about a thing that he likes to talk about. This is an industry standard that's been adopted by the Department of the Navy Chief Information Officer and by DISA. Now, what do we mean? How does all this fit together? So, first, let's start with our current architecture. We have a single computer running an application living behind a proxy, right? It's a fairly simple system with some weaknesses. So to improve this situation, what we need is to virtualize things. What does that mean? Let's go easy here. All we're really talking about is establishing a standards layer. So basically what we do is we break this down into the application stuff and its data and all of that, and then the platform layer below that. And as long as this platform is standardized, we are independent. We are platform independent. So we can run this on any platform or several platforms. That's a big deal. Now, why do I care about that? In the legacy model, if the server goes down, the one server, it's a big deal. It's all hands on deck because we have to get that capability back. In the new model, with a stack of servers potentially running the application, if one server goes down, nobody cares. We're running at reduced effectiveness for a few minutes until someone can bring a different server online. Reliability goes through the roof. So achieving 99.999% reliability is actually perfectly feasible with this kind of approach. So the second benefit that's really worth mentioning is that we get rid of this proxy server and build in authentication as a zero trust layer that makes for a far more robust and flexible authentication layer. Now, why is that a big deal? Well, that means that I can have this server in a space that anyone can get to. From a security standpoint, that sounds bad, but I'm about to explain to you why it's really good. Now, first, as far as usability goes, that means that the developers and the end users can get to the same space at the same time, which means that as the developers are working on things and deploying software, the users can get to the same space and provide feedback and can test it and can say, this works and this doesn't. Can you make this blue? We need this other feature over here. Developers also get to benefit from this because then instead of guessing about what users want, they can use real user feedback to drive the development of the software, which makes for more capable software in less time. This is a big deal. Now, security. Why is this more secure? The way we used to do security was you'd figure out whether or not the application met some security requirements as described on a paper document without actually testing the program. You put it on the server and you got a paper that says, here are the controls that are in place, right? Maybe there's penetration testing, but probably not. It lives behind a proxy. I can't really get to it from there. It just is what it is. With the new system, the DevSecOps approach forces us to do developmental security testing. So on the dev side, before the developer can even push it to the platform, there's built-in tests before anything even gets merged into the baseline. So automated security testing is a really big deal because computers are much better at doing very fine-grained, very highly detailed searching through code bases to find the sorts of mistakes that humans make that cause security problems. Second, once it's pushed to the repository, before it can go through, the whole repository has a series of checks that automate that process on the deploy side. So even if the code base was initially secure, maybe something in the compile or the image build or something produced a security vulnerability. And on the deploy side, that's checked again post-build. Now, this is really great because we can update those tests every day. If a new vulnerability comes out, if someone discovers some new weakness, we can update those tests in real time today to meet today's needs. Now, the other way that this is really cool is that if there's a today change in the deployed code, if we discover a problem that, some hacker somewhere has figured out a way to get to a thing, we've already deployed that, we can push that change today easily. It's not hard. I don't have to fly someone cross country. I provide the change, I update it, I push it into the repository, and it's done. That's pretty good. The other thing that's really good about having this in a common space that's easy for everyone to get to is that I can do penetration testing. So basically what this is just guys trying to break into the software, and it's usually a team of smart people who figure out vulnerabilities, and they scan for things, and they can find things in deployed environments that maybe were missed in either of the previous robust security steps. So with all of these improvements in security and reliability and user interface, it's really easy to see why everyone thinks that this is the right way to go. Now, unfortunately, we're not building from scratch. We have a tool and it works okay. How do we transition from a thing that works okay to a new system? Next up, how do we get there?